part of the topic 4 review. Ozone gas, O3, can be used to kill adult insects in storage bins for grain without damaging the grain. The ozone is produced from oxygen gas, O2, in portable ozone generators located near the storage bins. The concentration of ozone used are so low that they do not cause any environmental damage. The use of ozone is safer and more environmentally friendly than a method that used bromomethane, CH3Br. However, bromomethane was more effective than ozone because bromomethane killed immature insects as well as adult insects. Determine the total number of moles of bromomethane in 19 grams of bromomethane. And they give you the gram formula mass of bromomethane equaling 95 grams per mole. So they made your job easy here. So you're just taking 19 grams. Make sure you put grams on the bottom and 1 mole on top so your units cancel, and you get 0.2 moles, 19 divided by 95. This next question you can skip. I will go over it. We will learn it in an upcoming unit. They want you to identify the type of organic reaction, and I actually put the wrong organic reaction because I didn't read for clarity. A single replacement reaction is when one element pushes into a compound, which it did here, and pushing out another. So it is a type of single replacement reaction, but that's not the organic type of reaction. The organic reaction that this would be called is substitution, and that's because it's like when you go to the restaurant and your meal comes with, like, I don't know, meatloaf, mashed potatoes, and peas, and you don't like peas, and you say, can I get carrots instead? You have to give up the peas to get the carrots. So here, we're giving up a hydrogen to put on a bromine. So again, you don't have to know this yet, but I figured since it was here, I would explain it. So this is substitution. The second question you could be asked, based on the information in the passage, state one advantage of using ozone instead of bromomethane for insect control. And I underlined that as I read it, no environmental damage. All right, and moving on to the last question. A hydrate is a compound that has water molecules within its crystal structure. The formula for the hydrate, copper sulfate pentahydrate, shows that there are 5 moles of water for every 1 mole of copper sulfate. When copper sulfate pentahydrate is heated, the water within the crystals is released, as represented by the balanced equation. So we call the left side here a hydrated crystal. The copper sulfate is an anhydrous compound because the water was driven off, as you see here in the form of gas. A student first masses an empty crucible. You can see that here. The mass of the crucible is 19.24. Then the mass of the crucible with the copper sulfate pentahydrate in it is 21.37. If you take and subtract those two, you get just the mass of the copper sulfate pentahydrate. It's then heated to drive off the water, and it's cooled, and it's weighed, and then it's heated again, and it's cooled, and it's weighed, until we get a constant mass, which is what you see here, 20.61. We then subtract the mass of the crucible, and the mass of the anhydrous copper sulfate, meaning without water, is 1.37. They determined the mass of the water by taking the original mass, 2.13, and subtracting the anhydrous mass, 1.37, to get 0.76 grams of water. Identify the number of significant figures recorded in the calculated mass of the copper sulfate pentahydrate. 2.13, they're all integers, so that's 3 significant figures. Remember, leading zeros never count. Trailing zeros only count when there's a decimal. In the space below, use the student's data to show a correct numerical setup for calculating the percent composition by mass of water in the hydrate. I want to remind you all that this little dot right here does not mean multiply, okay? It's copper sulfate with 5 moles of water. That dot means with, okay? So when I'm calculating my percent mass, my part is the 5 waters, my whole is the whole entire compound. Circle is part, square is whole. So 1 water is going to be oxygen, 16, plus 2 times 1 hydrogen, so 18. So I did my mass of 1 water here. I multiplied it by 5 to get 90 grams. 90 grams represents my part. My whole is going to be the whole thing. So I have 1 copper, 63.5, 1 sulfur, 4 oxygens. That's 159.5 plus my 90. That's the whole, 249.5. I didn't actually show the correct setup, so let's do that. It's going to be 90 over 249, 249.5 times 100. I did all the work and didn't show the setup. All right. You didn't actually have to calculate it. You just had to show that, what I just wrote in purple. 90 over 249.5 times 100. Explain why the sample in the crucible must be heated until a constant mass is reached. And that is to evaporate all the water. And I noticed I did just show it down here at the bottom. 90 over 249.5 times 100. And I did the actual math on that, and it came out to 36%. All right, that's the end of topic 4.